This video will cover work physiology and specifically the use of the Cosmed K4b2 pulmonary, which just means related to the lungs, gas exchange system. What is work physiology? Work physiology is the study of how to enable workers to perform job tasks efficiently and safely within the work environment. It is interested in accurately measuring and evaluating the amount of energy needed to perform the job. There is another common field of physiology called exercise physiology, which is focused on how to get athletes to perform at their peak. Unlike exercise physiology, work physiology is interested in all kinds of people, not just athletes. The environment that work physiologists are interested in is not ideal and not controlled. Noise, heat, vibration, and other stressors add to the physical job demands of the job. Work physiology is used to enhance efficiency, monitor energy expenditure, and avoid excess fatigue. By understanding how the body is responding to the demands of the job tasks within the work environment, the work physiologist can work with safety professionals, ergonomists, and industrial hygienists to improve the environment or the design of the job to benefit the worker. Work physiology examples. Some examples of questions that work physiologists might be interested in are whether or not the job can safely be accomplished by people. Some jobs are so physically demanding that automation or machine assistance is necessary to complete the job. An example would be using an excavator to dig a trench instead of many workers with shovels. In addition to whether or not the job can be safely accomplished by people, can the job be completed within the required duration using available tools and methods that meet safety regulations? Another question to be answered is which methods of completing the job are easiest. By easiest, we may attempt to ascertain which job requires the least amount of energy. How we measure this will be discussed and shown shortly. Can a specific individual perform the job safely? What may be safe and acceptable for one worker may be far too strenuous for another worker. Therefore, the ranking of jobs according to physical demands for the purposes of compensation and fatigue avoidance may be necessary. An example of fatigue avoidance is the use of job rotation. Having a worker perform a relatively easy physical job in the morning, followed by moderately hard work in the afternoon, could help avoid fatigue compared to two moderately difficult jobs all day. Also, ranking jobs can assist with developing work-rest cycles. Work-rest cycles specify the duration of work to be completed before a rest is necessary for the worker's body to recover. Measuring worker performance. Work physiologists take several factors into account when measuring worker performance. The first are the effects of aging. Loss of muscle mass and diminished muscle reflexes are two outcomes of aging that can affect the ability of a worker to perform his or her job. Outside of personal characteristics, heart rate is a common manner of measuring worker performance. The relative ease of collecting heart rate and its correlation with energy expenditure, as shown in the graph, make it a great way to gauge how physically demanding a job is for a given worker. A final way to measure energy expenditure is through pulmonary gas exchange, or simply oxygen consumption and carbon dioxide exhalation. Just as heart rate increases with energy expenditure, so does oxygen consumption. New advances in technologies have made it easier than ever before to quantify the consumption of oxygen. This data, coupled with heart rate monitors, supplies the work physiologist with a greater understanding of the effects of the job on the worker. The Cosmed K4b2, or simply Cosmed, measures the volume of oxygen and carbon dioxide being exchanged, breath by breath. The Cosmed consists of three major parts: the mask that seals around the mouth and nose, attached to a tube to capture all gases entering and exiting the lungs; The second component is the data analysis and storage center, worn on the athlete in the picture's chest. This part analyzes the different components within the gas that is inhaled and exhaled and reports it live via Bluetooth to a computer where the raw data and graphs can be viewed. The final component is a rechargeable battery pack worn on the back, allowing the Cosmed to be taken anywhere. The Cosmed can be used in research in several ways. One of the most common ways, however, is to quantify the differences in physical demand between different jobs. One study conducted at Auburn using the Cosmed centers on the energy expenditure required for different crawling postures during an emergency evacuation. If the distance to the exit is far, energy expenditure is a crucial factor in determining how best to evacuate. Another way to use the Cosmed is to compare different methods of completing a job. By gathering the data from the workers, or by simulating the work in a lab environment and collecting the data that way, better determinations can be made for the optimal method of designing jobs. The following video shows the use of the Cosmed in the Auburn Biomechanics Lab. The subject is at rest and then begins a simulated occupational lifting task. Although there is no weight to the load of the lift, the high pace of the lifting task requires the subject to lift and lower his body several times a minute. This requires substantial energy, and the carbon dioxide exhaled shows the increased pulmonary activity and corresponding energy expenditure.
Now Bob is in a resting stage, so his oxygen and carbon dioxide level is more or less consistent during this period of time. And now he will start to do some simulated manual material handling tasks, basically lifting a box to the table. And then, because this requires more energy consumption, so more oxygen consumption, and will generate more carbon dioxide during his every breath. And then later we will see how that shows in the graph, which is captured by these devices called Cosmed. Okay, Bob, now start lifting the box. Okay, now we have a period of working time. Now Bob can stop the work and let's see how his carbon dioxide generating rate changes. So you can see at the very beginning we have a relatively small carbon dioxide generating rate because he's in a resting stage. After he starts to lifting the boxes to the table, the carbon dioxide generate much higher. If you look at the absolute value here, originally it's around 500, 600, and now it starts to hitting after when he's doing the manual material handling task, it's hitting 1800 line.